Retakes by Thursday, or retakes by Friday, I should say, but that's a 2-day process, so you need to get going on that sooner than better, because I'm not here Thursday, and we can do that before school, after school, during off months, all that fun stuff. But it's a go over it, study it, retake it kind of a thing. Test Thursday on 6-6. There's a book assignment and a review assignment. You decide if you need to do that, but there won't be a retake on 6-6. I can tell you that right now. Okay? That was a one-time option on 6.4. Okay? So that's that. And then Friday we need Chromebooks in class on Friday. Okay? All right? So let's talk a little background algebra. Okay? So if I told you, or if I asked you to solve for me 2x plus 3 equals 0, what would you do? Subtract 3 from both sides. Okay? Then what? Divide by 2. And so you would get x equals negative 3/2, right? Now, how many total solutions should you get in this particular equation? 1, right? Does anybody remember why we get 1 solution in this equation?
Because the x is to the first power.
Is that what you were going to say?
Sort of,
yeah. Okay. Because this x right here is to the first power. So that degree, we called that a degree back in earlier math classes. That degree tells us how many solutions we need. Okay? So looking at number 2, how many answers should I get? I should get 2 answers. Okay? How are you going to get those 2 answers? We're going to square root both sides. Okay? And the reason that we square root both sides is because then the left side just becomes x, and the right side becomes plus or minus 4. We need both of them, and we've always said that whenever we're taking an even index or an even root, we add that plus or minus when we're solving. Okay? Good to go on that? All good in said hood. Okay? Looking at number 3 now. How many answers should I get? I should get 2 because the degree, the biggest exponent, is 2. Okay, so I should get 2. Can I factor that? No. Can I square root that? No. So what's my other way? A little quadratic formula action on it. Okay, so then x is going to equal negative 2 plus or minus the square root of 4 minus 4ac. Well, 4 times 5 times 1 is 20 all over 2. Okay, 4 minus 20 is negative 16. The square root of negative 16 is 4i. So x here is equal to negative 1 plus or minus 2i. Right? And really, so that really is negative 1 plus 2i is one answer, negative 1 minus 2i is the other answer. Okay? That's really what that means. Okay? And there's my 2. What about x cubed minus 3x squared plus 2x equals 0? How many answers should I get? I should get 3 answers. Can I factor anything out of that one? Factor out an x? Okay. All right. So if I factor out an x, it'd be x squared minus 3x plus 2. Can I factor that trinomial? 2 numbers that multiply together to be positive 2 and add to be negative 3. What are they? Negative 2 and negative 1. So then this becomes x minus 2 and x minus 1. Now what? Bless you. Woo, that'll wake you up. So then we say x equals 0, x minus 2 equals 0, and x minus 1 equals 0. So I get x equals 0, I get x equals 2, and I get x equals 1. Right? So I got my 3 solutions. Yeah? Awesome sauce. What about x cubed plus 8 equals 0? How would you do that one?
You could subtract 8 on both sides.
Okay, so that would give me x cubed equals negative 8. And then what did you say? Then I could cube root both sides. Love it. What? No. What do I get? No. I get negative 2, right? Put it in this one so it's distinguishable. But how many do I need? Uh-oh. How many do those other two? Uh-oh. Let's do it a different way then. Okay? So, if I said that instead, if I went, what if I go, if I remember back to my Algebra 2 days, when we had difference and sums of cubes, right? And the factoring, this would be x plus 2 times x squared minus 2x plus 4 equals 0. Now, I don't expect you to remember that, but me as a math teacher, I remember. Okay? How to factor the sums of cubes, right? So then this would say x plus 2 equals 0. So then that gives me my x equals negative 2, right? Okay. And then this one would be x would have to equal positive 2 plus minus the square root of 4 minus 4 times 1 is 16 all over 2. Well, 4 minus 16 is 12, right? So that's going to be 2 plus minus 2i times the square root of 3 all over 2. So that gives me 1 plus I times the square root of 3 and 1 minus I times the square root of 3. Right? And now I've got my 3. Yeah? And that works for cubics. But what if this was x to the 5th plus 32? I don't have any formulas for factoring, a perfect fifth minus a perfect fifth, or perfect fifth plus a perfect fifth. So there's got to be another way. And that other way is actually using de Moivre. Okay? So let's start with de Moivre here now, back at x cubed equals negative 8. Okay? Can I write negative 8 as a complex number? Yeah, what is it?
Plus 0.
Negative 8 plus 0i. Right? And then we said, let's take the cube root of both sides. Yes? Okay. Well, taking the cube root of both sides is actually taking negative 8 plus 0I to the 1/3 power. Now, I've got a complex number taken to a power. How did we do that yesterday? How did we do it yesterday using de Moivre? What does it need to be in? Which form? Trig form, right? So let's put it in trig form. What is the R value of that complex number? Eight, right? What is the theta value of that complex number? (180°). Now, you may be saying to yourself, well, how'd you come up with those so quickly? Well, here's how I did it. So here is my real and imaginary system, right? And negative 8, 0 is straight out that way. 8 spots. So that gives me an R value here of 8. And it gives me a 0, 90, 180° theta value. Okay? So that, written in trig form, is going to be, x here now is going to equal 8 times the cosine of 180° plus I times the sine of 180°. And all of that is going to be taken still to the 1/3 power. Now we can apply de Moivre. What does de Moivre tell us that we need to do? What does de Moivre tell us we need to do? R to the 1/3. So that's 8 to the 1/3 power times the cosine of 180 times 1/3 plus I times the sine of 180 times 1/3. What is 8 to the 1/3 power? Cube root of 8. 2. 1/3 times 180. How much? How much? 60. Right? Now, let's put that back into standard form. What is the cosine of 60°? 1/2, right? 1/2 times 2 is 1. What is the sine of 60°? Square root 3 over 2 times 2 is square root of 3. Yep, so it's I times the square root of 3, right? Well, let's go back now to my original problem, and whoops, there it is. We just found that one. But how many more do we have? We've got 2 more to find. So here is the extra kicker. On the side, you're going to take 360 and you're going to divide it by 3. And where I got that 3 from was right here. It's the root that you're taking. So in this case, we're taking the third root, so that's going to be 3. If I was taking the 18th root, I would divide by 18 there. Okay? So what is 360 divided by 3? 120, right? So now, to find the other ones, I'm going to add 120 to those two thetas. So my next root is going to be 2 times the cosine of 180 degrees plus I times the sine of 180 degrees. Right? Well, what's the cosine of 180 degrees? -1 times 2. -2. What's the sine of 180 degrees? 0 times 2 is still 0. So that's 0i. Or we would just write that as -2. Is that one of our other solutions? Yeah. Okay. Now, so we got to find a third one. So now I'm going to add 120 degrees onto that theta. So that's going to give me 2 times the cosine of 300 degrees plus I times the sine of 300 degrees. Okay? What's the cosine of 300 degrees? Cosine of 300 degrees is 1/2 times 2 is 1. What's the sine at 300 degrees? -√3/2, right? Times 2 is -√3 times I. Right? And there's our third one. I added 120 to 180. I added this to there. Now, what would happen if I added 120 to 300? Where would it be? So 120 plus 300 is 420, which we only go up to 360, right? So what's 420 minus 360? 60. So I get back to my start. So those are the 3 roots of -8. Okay? So let's simplify that plan. Okay? The first thing that you are going to do is you are going to put it in complex form. So 27 written in complex form would be 27 plus 0i. Yes? Then you're going to take the root to both sides. Okay? So that's going to be the third root here and the third root here. So that's going to leave me with x here equals 27 plus 0i to the 1/3 power. Now what do we need? If I'm going to use de Moivre, I got to have it in trig form. Now, if you would have trig formed it right from the start, that's fine too, right? But you'd have to get it in complex number form first in order to get it in trig form, right? Okay. So, side note, 27 is way out here, right? Okay. What's my R value? 27. What's my theta value? 0. So this is 27 times the cosine of 0 degrees plus I times the sine of 0 degrees. Then what? Demov, or if you were in the first class today, it was demovie. I forgot the R. Okay. So that's going to be 27 to the 1/3 power times the cosine of 1/3 times 0 plus I times the sine of 1/3 times 0. 27 to the 1/3 power. Three, right? Cosine of 0 degrees plus I times the sine of 0 degrees. Right? Now, the nice thing about roots and solutions to equations and stuff like that is we're only going to ask for them in trig form. So you can leave it like that. You don't have to convert it. Okay? We can leave it just like that. But that's only one. And then to get the others, we have to do our 360 divided by the root, which in this case, it was 360 divided by 3, so that's 120 degrees. So my other two roots here then are 3 times the cosine of 120 degrees plus I times the sine of 120 degrees, and 3 times the cosine of 240 degrees plus I times the sine of 240 degrees. And there's my three roots, my three solutions. Okay? Now, the tweak of this is this particular problem. Okay? Where we say, find the fifth roots of a certain number. Okay? That's the two different kinds. The one kind is going to be, here, solve this equation. X to the fifth equals something. Or x cubed here equals 27. Or we could just say, find me the fifth roots of that number right there. Okay? Well, it's done the exact same way. Okay? The only difference is, so this one's already in complex number form for us, right? So we want to take the fifth root of that. So it's going to look like that. Then I need to convert it into trig form. Yes? Okay. So trig form here, that would be what? So my R value would be negative 16 squared plus 16 square roots of 3 squared. And then take the square root of that one. So that's what? 256 plus 16 squared, so 3 quantity squared. 256 times 3. 768? Yes? You guys all have calculators. 16 times the square root of 3 squared. 768. Thank you. Thanks, Savannah. Okay. 768 plus 256. 1024. Running out of things to throw. What's the square root of 1024? 32. Okay. Now what? Theta, right? Inverse tangent of the square root of 3 is what? 60 degrees. It's one of those that you should know. Okay. Which quadrant is this in? Quadrant 2. So that my actual theta then is going to be 120. Okay. So we can convert this into 32 times the cosine of 120 degrees plus I times the sine of 120 degrees to the 1/5 power. So this is 32 to the 1/5 power. What is 32 to the 1/5 power? 2 times the cosine of 1/5 times 120 so that's going to be 2 times the cosine of what? 24 degrees? So there's my first one. But now what do I have to do? 360 divided by 5 is 72. Okay? So I have to add 72 to my thetas. Well, what is 24 plus 72? 96. That's 2 of them. How many do I need? I need 3 more. I need 5 total. So what's 72 plus 96? 168, you said? What's 72 plus 168?
40.
What's 72 plus 240? 312, did you say? What's 72 plus 312? 24, right? So I'm back to the beginning. Because really 72 plus 312 is 384. Bring it back inside my first lap, gets me at 24. Okay? So there's my 5 roots, the 5th roots of negative 16 plus 16i square roots of 3. Yeah, buddy? Don't forget that you have a test on Thursday. It will cover all this stuff. Tomorrow, my plan is to do a couple more of these and then open up the floor for questions and reviewing and all that fun stuff in preparation for the test tomorrow. Okay? Technically, you have learned everything that you need to learn for the test on Thursday. Okay? All right? It's just more practice is needed in this stuff. So, yeah, buddy.